Here, a kind of a similar question has appeared again, but this time with capacitor also. Inductor is also there, capacitor is also there, and we know the comparative behavior of both capacitor and inductor. If we say that at time t is equal to 0, capacitor 0 resistance. Okay, at time t is equal to 0, and when time is 0, at that time this L behaves as infinite resistance. Okay, so L at time t is equal to 0. After a long time, that means if t is equal to infinity, in that case, what happens? C offers infinite resistance. No current will pass through the branch where the capacitor is connected. So it offers infinite resistance. And as far as the L is concerned, L offers no resistance. It offers zero resistance after a long time. So we can see here that in both the circuits, if they are switched on at t is equal to 0, then immediately after the t is equal to 0, the charge on this capacitor has to be 0, because here the current will grow gradually. In this case, the growth of the current can be written as I is equal to E by R bracket 1 minus e raised to the power minus t by tau, where tau is time constant and is equal to RC. And here we have already seen that I is equal to I naught bracket 1 minus e raised to power minus t by tau, where tau is what? L by R, and is time constant of this circuit. So charge on C just after t is equal to 0 is C into E into C after t is equal to 0. No. At time t is equal to 0, the charge on the capacitor has to be 0. So this one is wrong. The charge on C t is equal to 0 is EC. The charge on C long after t is equal to 0 is EC. So this one is correct. Anyway, we'll continue to check the rest. The current in L just before t equal to T naught. What is T naught? The switch in the following figures are closed at t is equal to T naught, 0, and respond after a long time at t is equal to T naught. Means switch responds when the current attains a certain value. But in both the cases, the actual steady state value comes only after a long time, after infinite time, which is not achievable at all. So what we do, we normally end up it to be, say, if the 99% of the job is over, then we say that it is 100% almost. Okay, so after a long time, the charge on this will be CE. And similarly here, as we know that at time t is equal to 0, as soon as this switch is kept on, at that time, what will happen at t is equal to 0? L will offer the infinite resistance. So it will offer infinite resistance at t is equal to 0. That means at t is equal to 0, no current should flow through this circuit. So current in L just after t is equal to T naught is E by R. The current in L long after t equal to T naught is E by R. This has to be correct. This option is wrong. So these two options are correct, Q and S. So here we can see that our option C will be the right option. Okay.